So good morning, FOSDEM. My name is Sébastien. I'm a rock on the internet, and this is Adrien Béraud. I'm a Ring developer since last July, and Adrien since the beginning. Today we will talk about Ring, what is Ring, how it works basically. And 2017 was a big year for us, so we will present the new feature and what we want to do for this next year. So what is Ring? To define Ring, I can say that Ring is a free, universal, distributed communication platform which respects privacy. It's a software developed by Savoir-Faire Linux, a company in Montreal. Yeah, I know it's a lot of words, but Ring is free because we use the GPL license for the whole code and free open source library like GNU-TLS, PGZip, etc. It's universal because you have clients on every platform like iOS, Android, Linux, Windows, etc. It's distributed because we use peer-to-peer technologies to do that, like OpenDHT. It's about communication because we use Ring to share files, send text, messages, and do video conferences. It's a platform because you can use some parts on every project, like the daemon or OpenDHT, and which respect privacy because we do end-to-end encryption, and we try to do Ring as secure as possible. So let's start for a little demonstration. So this is the interface on GNOME, and you can do video calls. Like, call me. It's a little bit black, but this is you. Also, you can send text messages, etc. So, how it works? First, what is a distributed network? Basically, you have three types of networks. You have applications like Skype, which use a centralized network. You basically have one server which does the authentication and all data pass through. You have things like Riot, Matrix, or Mastodon, which use decentralized network. It's about a federation concept where some servers are connected to some others. And you have things like Ring, which use where any device is a node on the network, and the network is basically a mesh. We will present OpenDHT in details in the RTC room in 30 minutes, I think. So you have OpenDHT, the base for the network. And when you launch Ring for the first time, you will generate a RCA key pair. It's basically your account, and it can be self-signed or signed by a CA. And for each device, you will generate a new key pair for your device, and you sign with a previous one. And the Ring ID is basically the fingerprint of your public key, is your identifier on the network. So to contact another, to contact someone, you need to know his fingerprint. But fingerprints are hard to remember. So we designed the name server. It's basically a piece to translate Ring ID to nicknames. And we store it on a blockchain. But you can use your own, you can host your own name server on the database. For example, you just have to answer to a REST API, which is described on the wiki. And it's optional. You can just use a Ring ID and no nicknames if you want.
Yeah, so Ring uses two distinct distributed networks to work. So one of them is the Ethereum blockchain that is used for name registration, and the other one is OpenDHT. So this is an example of how it works with OpenDHT when you want to reach someone else on the Ring network. So here Alice wants to join Bob. So Alice will use Alice will use the OpenDHT network that we will describe in the RTC room to make. So OpenDHT, it's a distributed dictionary. So every member of the OpenDHT network will have access to a shared global dictionary. And this global dictionary will be used to exchange information between peers. All of these packets exchanged on OpenDHT are encrypted. So here to join Bob, Alice will make a put on a given key, a key that is derived from Bob's public key. And Bob will make a listen operation on that key. So this listen operation means that Bob will be informed of any change of value for that key on the distributed dictionary. Yeah, so after Bob received this information on the DHT, Bob will reply on the DHT also to Alice. And so what the exchange basically will be their encrypted IP addresses, which are then used to perform a nice negotiation. So a nice negotiation will attempt to establish a direct peer-to-peer connection between Alice and Bob using the IP addresses that were exchanged over the DHT. This ICE negotiation, when it succeeds, then will provide access to a direct peer-to-peer connection, or it might fall back to a turn server, for instance, if one is configured, that will relay the connection in case there's no possibility to have a direct peer-to-peer connection, like if both peers are behind a different private network. Once a peer-to-peer connection is established, it is encrypted and authenticated through a DTLS connection. So the DTLS connection, when it is established, is used to do peer authentication. So they will exchange their respective certificates, and that will be used to check that it is actually the identity that we were trying to reach. And also, obviously, it's used for encryption. And over this DTLS channel, there is a classic SIP communication that is used to negotiate the call or messages or whatever. And yeah, the result is then we use this peer-to-peer DTLS connection to make audio-video calls, exchange text messages, etc. We try to make Ring as universal as possible, so we build clients that are as easy to use as possible for the general public. We try to make clients as user-friendly as possible. So as Sebastian mentioned, we have clients for Android, we have a client for Android TV, for iOS now, for Windows, we have a UWP client, and obviously on GNU Linux, and also on macOS. So the demo was between the macOS version and the GNU Linux version, which is a GTK. So we just released a new version last week, which includes support for iOS. We recently added support for Android TV. It works actually pretty well. It's really a pleasure to use Ring on Android TV. You can have Ring in a conference room, a meeting room, and use it, and it's really seamless. And actually, it's the only communication app available on Android TV. There's no other communication app available on Android TV. And we are also in communication with the F-Droid community to keep Ring updated on F-Droid. In this new release, we also added major new features that were missing in Ring. So we added the file transfer support. We added support for push notifications. So this was a challenge because there were obviously we want to be fully distributed, and push notifications require some authentication to a push server either Google or Apple. So we try to make it, to keep the distributed mechanism. We'll talk more about it later. So we added the possibility to have a DHT proxy, so the distributed network running this DHT node. Every ring instance runs a DHT node by default, but we added the possibility to have to use a deported DHT node, so a DHT node running on some other computer. And so every operation on the local DHT node will be proxied to the remote node. And why we want to do that? The reason is that running a DHT node is lightweight, but on the long term on a mobile device, it still uses much more resources than just doing nothing, because there are many small packets to maintain the connectivity going on. So it keeps the phone on, it keeps the radio on because it sends and receives packets on a regular basis. So on mobile devices, there is a need to have a DHT node that is not running on the phone itself. And also it was a demand from the community. So because since it's a distributed network, IP addresses are visible on this distributed network. So some people want to hide their IP address. So they can run the DHT node maybe on their own server or at their home and configure it on their phone. So when they move around, their IP address is not exposed from their phone. And so we massively improved contact management, which was an issue in previous Ring versions.
So we had a lot of features in 2017. First, we had a searching item on the GNOME version. So, for example, if I search an essay, you will have a searching item when the contact is not found, and then it will transform to another thing. After that, you can add the contact or just send a message on it. It will be automatically added to your list. We worked on a common database for all clients, so we can, in the future, synchronize all clients, history, contacts, etc. And we had a lot of bugs on contact duplication before that. We also had the ability to change passwords. The problem with Ring, it's not a problem, but when you generate an account, you will have a tar.gz encrypted by your password, and you can change this password. In Ring, you don't have any possibility to recover a password. You don't have a server to contact for, I forgot my password. It's just an encrypted file on your device. But now you can change the password on the device. We also had the hardware acceleration support on macOS and Linux, I think. And well, this is the schema of the database, and this is the searching item. In December, we had the possibility to share files. Before that, for sharing a video or an image, you had to call your contact and share the file, but your contact couldn't save the file. So now we use TCP over turn over TCP connection to do file sharing. But in the future, we need peer-to-peer implementation, like a torrent or something like that. Like Adrien said, we had the possibility to use another node on the network to do the listen on the DHT. Your node on your device will just decrypt the value on the DHT and pull the proxy to retrieve the value. It avoids the synchronization on the device and save battery and data consumption. And yeah, messages are still decrypted by the device because just your device have the correct key to decrypt it. Oops. Um, we also add the push notification support with the proxy. The problem with that is you have a push provider from your device vendor, like FCM for Android and APN for Apple, and you need authentication. So basically, you need a key or a password, and this is stored on a server. So we stored this information on a push gateway hosted by Savoir-Faire Linux. And your OpenDHT node will just use the gateway to send notification. But you need a central point to use push notification. And the thing is, for Apple, for example, you can't have an application in background H24. So you need something to wake up your daemon, and that's why we implement it. So what we want to do in 2018, we have a lot of ideas. We want to improve auto video quality algorithm. For now, we just use network packet loss, but we can use the feedback provided by RTCP or RTSP. We need a peer-to-peer implementation for file transferring. We need to connect Ring to other technologies like the telepathy client. We need to connect Ring to Matrix as well as possible, like the XMPP bridge. And we need to do a WebRTC client to have directly Ring in your browser, for example, like Pharmatalk. And we need to improve the community aspect of Ring. We have a community which does the packaging, the translation, building scripts, support on the mailing list or on the Tulip, testing open bugs, open tickets. We also have one guy who makes mock-up for the design of the GNU Linux client. And somebody asked us if he can do the security verification. So we have a pretty active mailing list, ISC channel on Freenode, and Tulip for ticket tracking, bug tracking. And we want to participate to the Google Summer of Code this year with previous ideas. So thank you. If you have any questions, you can download Ring with your instruction on the website. And this is technical information about Rings. Thanks.
Working? Does Ring have does it work without a connection to the internet? This local peer discovery or something that makes it work?
In fact, you can have a bootstrap
Yes.
on your local network and use Ring without any connection, just on a local network.
It will work, okay.
It will work.
And another question, why didn't you use a Namecoin?
Yeah, so just about your first question, yeah, so Ring was designed to be able to work on a local network, on a private network, even with multiple layers of private networks in it. Yeah, and we didn't use Namecoin. Well, when we designed the name service, it just felt like Ethereum provides more flexibility to evolve later. Yeah, basically. And I think Namecoin was created before Ethereum, and I think Ethereum, yeah, provides more flexibility to write custom rules about how to handle names and etc.
Can you share one identity between various devices?
Yeah, you can. I've got an account on my GNU Linux client and my Android one, and it works.
Yeah, so it was like the third slide which show how it works. So basically we have an account certificate that will sign device certificates. So when you connect on a new device, it will sign a new certificate for this device, and the device will authenticate, and accounts will authenticate each other's by their certificate chain using standard certificate chain verifications.
Just a quick one about the Namecoin issue. Also, if you look online, there was another project, I forget which one, which evaluated Namecoin and found that it was actually suffering from a 50%, 51% attack at the time. So that might be another reason not to consider it. But also, have you considered using OpenNIC, especially on those platforms where you can have some control over the DNS servers? You could actually provide a completely free means of getting an identifier. Might be something to look at in the future.
Yeah, definitely. So actually, the way Ring communicates with the blockchain is through a REST API. So the blockchain could be easily replaced to connect with any existing named user directory. So, for instance, an organization could connect this name service to its internal user management system, or it could be connected to other services.
You can just have a JSON file on your website and it works for get name Amarok and just.
Could you go back to the slide with the DHT, like Alice and Bob? Because I think you might have a privacy problem, which is kind of the same that we have with Tor Onion service and in the previous iteration of the protocol. No, the one with the drawing. Yes, so the position of the computer that is going to receive the put and forward the listen call is only determined by the call to, like the device identifier, right? So I can predict which computer I need, which key I need to be in, like which place I need to be in the DHT, and then I can monitor every call that are going to be passed to Bob, which might be a privacy concern. Like in Tor, we had to invent this new protocol that is like a shared random identifier that changes every 24 hours. That is like makes it way harder for someone to actually put themselves in the right position with DHT. So, yeah.
Yeah, so indeed, protecting the privacy, users' privacy on DHT is a real challenge. So we always consider the DHT itself as, I mean, we never trust the DHT as is. We use it like everything that is put on the DHT is encrypted. However, it's true that people can use the DHT to observe what's going on. So that they will see encrypted values, but it's true that they can use it to infer metadata or this kind of thing. And we are still working on it. I mean, to my knowledge, there is only Tor that provide a very consistent way to hide the IP address, and maybe some other similar technologies. So, yeah, we might go toward this in the future. It's still an ongoing research.
Hi. What happens if I send a message to a friend of mine and the friend is offline for the next few hours? How is the message delivered, or what feedback do I get?
You will see a failed status because message is stored on the DHT 5 minutes, and after that is deleted. So you need to retry when it's connected.
But if you try to send a message and the other person is not connected, your device will still try to send it a few times afterward, like I think every 10 minutes for 3 times, and then it will set that it's failed. So yeah.
So I thought from your first explanations that only I want to talk to you message was sent through the DHT, but from what you've just said, apparently the first message is sent as well through the DHT.
The first one.
If I say hi to Bob, will hi be sent or I want to talk to you be sent through the DHT?
Okay, so if you are, so currently currently the strategy is that if you just send a message to someone that you just have in your contact list, it will send an encrypted message over the DHT. And if you have a current call with the person and you send a message, it will use the peer-to-peer connection to send the message.
Okay, so technically, if later in the future my RSA key is lost or broken or something, the first message of every new conversation could be recovered if an history is stored somewhere?
Yeah, indeed. The messages on the DHT are not forward secure. So indeed, if your RSA key is stolen or anything, messages exchanged over the DHT can be decrypted. So that's also an improvement we're working for the future to have forward secrecy on the DHT. And when you have a peer-to-peer connection, it will use TLS ciphers with perfect forward secrecy only. So then your peer-to-peer connection and then every message exchange on it will be perfect forward secure. And the reason is we want people, the design is as it is right now because we want people to contact each other without a first exchange, or we want people to be able to send messages even to people that have never reached before, so then don't have the opportunity to exchange a shared secret or this kind of thing. But this design will likely be improved.
Time is up. Thanks for the presentation.